Okay, so today we are going to be doing the ions and ionic compounds practice problems. We're going to go over them. But before we do that, we really need to write some things on the periodic table. Now, I'm going to make this periodic table just a little bit bigger so we can actually work with it. Okay, so starting with group 1, where the hydrogen is, we're going to put a +1. Actually, we're going to put a 1 plus. Because that group is going to have that one valence electron. It's going to lose it, which means it has one extra positive charge. Now, group 2 is going to have a 2 plus charge. Okay. Now let's move these over. Now the transition elements we are not even going to touch. We're going to come back over here, and now boron, aluminum, gallium, they have 3 valence electrons. They're going to lose those 3 valence electrons, making them a 3 plus. Carbon, silicon, all of those guys, they are, I always put plus or -4 here. I know you're supposed to put the sign afterwards. Most of the time, they're going to form covalent bonds rather than ionic bonds, but every once in a while they do. If it does, we'll put the 4 plus or the 4 minus. I just don't like the way it looks behind it. Oh well. Now, we're going to go to nitrogen. That's in group 15. They have 5 valence electrons. Now remember, the magic number is 8. So it either can get rid of those 5 electrons or gain 3. It's much easier to gain 3 than it is to lose 5. So it's going to have a 3 minus charge because it's going to have 3 extra electrons this time. Oxygen is in group 16. It wants 2 more electrons. So it's going to have a 2 minus charge. And then fluorine is going to have a 1 minus charge because it has 7 valence electrons and it only needs 1 more. Now, all the guys in the noble gases, we don't even worry about them because they're not going to be getting electrons or gaining electrons or giving them away or anything like that because they already have a full valence shell. Okay, so let's go on to the actual practice problems. Okay, so let's look at lithium. Actually, let me make these a little bit bigger. It makes it a little bit easier to write. Okay, so lithium is in group 1. So lithium is going to have a +1 charge. Now, when we write the charges, usually if it's a 1, either a +1 or a -1 or 1 plus or 1 minus, we leave out the 1. We wouldn't have put a plus sign if there wasn't at least a 1 charge. Okay, so now let's look at magnesium. That's in group 2. So it's going to be 2 plus. Nitrogen is in group 15. So nitrogen is going to have a 3 minus charge. Fluorine is in the last one, so it's going to be an F minus. No, that's not a grade of F minus. Okay, let's look at sodium. Sodium is in group 1. So sodium is going to have a +1 charge. Barium is in group 2. So barium is going to have a 2 plus charge. Oxygen, group 16. It's going to have a 2 minus charge. Okay, let's go back up here. Bromine. Bromine is in group 17. So bromine is going to have a -1 charge. Arsenic is also in group 15. So arsenic is going to have a 3 minus charge. It's just like nitrogen. Selenium, group 16. So it's going to have a 2 minus charge. Okay, let's pull these up again. Cesium. Cesium is in group 1, so it's going to have a +1 charge. Potassium, also +1 charge. Chlorine. I think you guys get the idea. Okay, iodine. Let's see if there's any more below this. No. Oh, I forgot potassium over here. Potassium has got a 3 minus charge. Okay. Let's go back to this side. Rubidium. Rubidium has got a +1 charge. Sulfur. Now, sulfur is in group 16, 2 minus charge. Tellurium, same thing. Tellurium, 2 minus charge. And then we have antimony, which is in group 15. So antimony is a 3 minus charge. And the last few, we got calcium. Calcium's got a 2 plus charge. Tin. Tin is in that carbon. So tin could have a +1 or +4 or a -4 charge. Now, one of the things, if you'll notice, tin is on the left-hand side of that squiggle line, which means it is a metal. And if you remember from last unit, we talked about metals. Metals lose electrons. You won't ever see tin with a -4 charge. It is not going to gain 4 electrons. So tin is one of those we're going to put a 4+ charge on. Okay. Beryllium, let's see, beryllium is in, what is that, group 2, so it's going to be a 2+ charge. So hopefully you've got those answers. If not, if you don't understand this, ask me tomorrow because I will be back in class tomorrow. Okay, so now let's work on the chemical formulas for the ionic compounds. Okay, we got to make this bigger. So I'm going to make them a lot bigger and give myself a lot more space to write. Okay, so let's look at the first one, calcium and oxygen. Calcium is a 2+, oxygen is a 2-. Guess what? They're the exact same number. So what's going to happen now is they're going to cancel each other out. So we're just going to have a CaO. We don't have to worry about crisscrossing numbers down. Nothing like that. Okay, let's go to the next one. Boron and phosphorus. Boron has a 3+ charge. Phosphorus has a 3- charge. Once again, they're the exact same numbers. So we can put BP. Not a good gasoline company, but, you know, boron phosphide is a pretty good compound. Okay, let's look at rubidium and sulfur. So rubidium has a +1 charge. Sulfur has a 2- charge. So here we're going to crisscross that 2 down, but there's no number on the rubidium. Now remember, when we write these charges, we never write 1+ or 1-. Okay, the 1 is assumed, okay, when we write the ion down. We wouldn't have written a plus down if there wasn't at least 1, right? Okay, so on this one, the rubidium gets the 2. Okay, so this 2, the 2 from the sulfur got crisscrossed down to the rubidium, but nothing goes with the sulfur. So you have Rb2s. Okay, let's look at aluminum and fluorine. Aluminum has a 3+ charge and fluorine has a - charge. So this time we're going to take the 3 and move it over here, but there's nothing on the fluorine to crisscross back over. So this one, we have AlF3. So 3 alphs. Okay, so let's go on a little bit further. Now, transition elements. There are 3 that we have to be aware of. And I'm pretty sure I put them in the notes, but I'm going to review them right now. On your periodic table, you need to go back. And silver has a +1 charge. And zinc will have a, 1+ charge, yeah. And zinc will have a 2+ charge, okay? So those are 2 that the charges are known. So they're the only, there's a couple more, and we'll go through the little triangle thing shortly. But those are the main ones that have only 1 charge out of all of those transitions, okay? Copper, nickel, cobalt, iron, manganese, all of the rest of them have several different charges. Silver is a +1 and zinc is a +2. So we're going to start with that one. So silver has a +1 charge and oxygen has a 2- charge. Okay. So we're going to crisscross this 2 over here, but there's nothing coming from the silver. So we have Ag2O. Hopefully you're getting the hang of it by now. Okay, let's look at calcium and phosphorus. This one's going to be a little harder. So we got the 2+ from the calcium and the 3- from the phosphorus. And I think when I was doing the notes, by the way, I was writing them backwards, which you could write them the other way, but I actually like writing them this way better because it shows you that just the numbers crisscross down. It's a little bit easier to do the crisscrossing. But if you want to write down +2 and +3, you can do that too. Okay, but technically the accepted method is the 2+ and the 3-. So like over there at P where it says iron 2+, and lead 4 plus. That's the accepted method of doing it, not +2 or +4. Okay, so let's look at over here. So this time we're going to take this 2, that's going to go over here, and this 3 is going to go over here. Okay, so that means the calcium gets the 3 from the P, and the phosphorus gets the 2 from the calcium. Okay, now let's look at the next one. We got aluminum and oxygen. So aluminum has a 3 plus charge. Oxygen has a 2 minus charge. So the aluminum, we're going to actually crisscross the 3 over there and do the 2 over here. So the aluminum is going to get the 2. The oxygen is going to get the 3. Okay, so now where we are. We're on beryllium and sulfur. Okay, beryllium. Beryllium is a 2 plus, and sulfur is a 2 minus. So guess what? They're the same. So it's going to be BES. Okay, well, let's do one more, and then we'll probably go through, and I'm just going to write them down. I'm not actually going to talk through them. I'm just going to show you how they are so you can check your answers. Okay, so the next one is zinc. So we got zinc 2 plus and selenium 2 minus. So you get ZnSe. Strontium, let's see, strontium 2 plus. Iodine is a minus. And only that goes down there. So SRI2. Okay, so let's go back over to the other side. And hopefully you guys are getting it by now. Now, gallium is a 3 plus. And bromine is a minus. Crisscross them down. And we get GaBr3. Uh-oh, the 3 didn't show up. Okay. Now, boron and oxygen. So we get B2O3. Okay, hydrogen, oxygen. Oops, that's a 2 minus. Just my eraser. There we go. 2 minus. 2 goes over there. Guess what? It's H2O. And you guys know what that is, right? Water. Okay, hydrogen and phosphorus. Oops, that didn't go very far. 3 goes here. We have H3P. And by the way, that's phosphoric acid, if anybody wanted to know what the name of that was. Okay, potassium and bromine. No charges, no numbers at all, which means they cancel each other out and you get KBr. Now, iron, I'm giving you the charge on it. Remember, iron has many different, well, a couple of different charges. So we're going to use the 2 plus one and then the bromine because I gave it to you in the problem there. So it's going to be FeBr2. Now let's go to lead and chlorine. Lead's the same way. Pb. Now I know it's under group 14, just like tin, but lead will have more than one chart. It has a +2 or a +4. Tin's the same way, 4 plus or 2 plus, but most of the time it's the 4 plus. So we're going to use that 4 plus there, and then the Cl, which is a minus. Put the 4 over there. We got P. Oops, shoot, hang on a second. I can't write today. Pb. And then Cl4. Okay, nickel with its 2 plus, oxygen with its 2 minus is NiO. And the last one, or last couple rather, we got scandium. Oops, hang on. Uh-oh. hang on. Oh, for some reason, it wouldn't write very well. Okay, so I got scandium, which is, oh, it's moving. Okay, hang on, there we go. Scandium is an SC. Well, hold on. Okay, so let's start this again. Scandium, SC. Now, that one is a +3. It's also one of the few. So you can actually put +3 in there. Now, some places on the internet, it may say scandium has more than one charge, but every place I've ever seen, it just has one charge. So as far as you guys are concerned, it's got a +3 charge. So that's another transition element you need to put a 3+ in. Okay. Then phosphorus is a 3-, so you get SCP. Okay. Now we're going to go back up again. We got mercury, which is Hg plus, and then sulfur, 2-. So that goes over there. So we have Hg2s. Okay, so hopefully you guys understood this. After this, I'm going to give you one more. Well, there's another video that I actually want you to watch tonight, and that is on there. So watch that video. You can do it in class. Hopefully you have time in class. Otherwise, it is homework. And then tomorrow I will see you in class, and we'll go over, probably do a warm up on the video. And then there's an activity we want to work on. So everybody have a good day. Bye.